that glare is kind of annoying, huh? So yeah, solid particles vibrate. Very compact, very close together. I'm going to give you all the notes on solid right here, on solids next to it, then I'll put liquid up, then gas, and that's going to be it for today, I'm sure. All right, so solids. Closely packed particles. Closely packed particles. And I use the word particles because atoms, molecules, ions are all particles. So an atom is just a circle, and then a molecule is two touching. So in this case, these are all individual atoms, just very close. So anyways, that's why I use the word particle. Closely packed particles, solids, have definite shape and volume. Definite shape and volume. Cannot be compressed or expanded. And my question to you is, oh, and let's write, they vibrate in place. Let's write that. And then these two here, the definite shape, definite volume, my question is why? Why does a solid have definite shape and volume? If I take this marker out of the room, it doesn't change shape. It doesn't take up more or less space if I bring it somewhere else. It's definite, it's not changing. Why can't you compress? Why can't I compress this to take up less space? Why can't I expand it?
Because everything's already compressed, right?
Why can't I expand it then?
Because it's stuck together.
Because it's stuck together. There's two answers here. She's not wrong. Who's it gonna be? Caitlin Hall. Can you move your desk back at all? Why? Because Maddie's, your desk's actually touching the desk and the chair. Pretty much. Can you move forward? Why? Because there's no room, right? He's right in front of you. So what's my analogy? Why can't we expand this? Hold on, I'm talking to Caitlin here, people. Why can't you move front? Why can't you go back or forth here? Because there's no, right. So why can't this expand? Just say the same thing. There's no room. The particles are already basically touching. So you guys have spaces between you. If I pushed all the desks together, that would be more like this image, right? This desk here, all right, particles are very similar to this, okay? So the reason you can't expand or compress is because the particles are right on top of each other. They can't go anywhere. You try to expand, they smash into the ones next to them. You try to compress, they hit the ones next to each other. So why? Because the particles are so close. Particles are so close. There's no room. Why are they so close? Right. Just like people. If you're attracted to somebody, you want to be close to them. Right, Cody? That's right. So they have strong forces of attraction. Strong forces of attraction between the particles. So the particles are really attracted to each other. Think like magnets. Okay, strong magnets. Very hard to separate them because they're really attracted to each other. Okay? So that's solid. Liquid. The notes for liquids are almost exactly the same. Almost. A little bit different, but pretty close. I'm going to erase this all though and start over. Hopefully you guys are with me. Got to zip through this so I can get to gas. So liquid particles here. Liquids have definite volume. In other words, the amount of space it takes up doesn't change, but their shape can change. Right? So you can pour a liquid from a graduated cylinder onto the table. So in a cylinder, it looks like a cylinder. And then when you pour it on the table, it flattens out to try and take the shape of the top of the table. So the shape can change from liquids. You guys know that. Okay. So definite volume, but shape cannot. Shape can change. But again, the amount of liquid doesn't change. Right? If I put a couple drops of water on this table, it doesn't magically fill up the whole table. Right? It's still those little drops, little tiny volume. So volume stays the same, shape cannot. Particles, are closely, no, don't write that, are close to each other. Particles are close to each other, but free to move around, and we use the word flow. So move and flow. They're free to move around and flow, and that's because their forces are slightly weaker than solids. They're still, I use the term fairly strong. If you have friends in period 2 and you ever look at notes, I rarely use exact same wording, which is fine. But for them I wrote fairly strong forces, meaning slightly weaker than solids. This is probably a better way to say it. Forces are slightly weaker than solids. Okay? That's why instead of just sitting there vibrating, they're able to break free a little, and move around. That's why liquids flow, okay, and can move and slosh around and stuff, because their forces are a little bit weaker. Cannot compress or expand liquids. It's the same explanation. This image actually is not a great image. So why use it? Because there's not a lot of good ones out there that are big enough and clear enough and really show the difference. I don't want you to be confused. So this is good for you to see, okay, it's more disorganized. What's the word for that?
Clutter.
The level of how disordered something is?
Oh,
Entropy, right. Solids have really low entropy, gases have the most, liquids are in the middle. There's a little more chaos here, okay? That's why I use it. But this space here, way too big. Particles are still pretty close, so you can't expand or contract liquids. Kids say, wait a second, what about evaporation? Well, that's a gas. Once a liquid evaporates, it's not liquid anymore. It's a gas, it's a vapor. So then these don't apply to the vapor. Okay. Last one, gas. Get as much as I can here before the bell. So gases, I don't think I actually labeled liquids, hopefully you did.
Yeah.
Gases, particles,
Are we gonna draw a picture for this one?
very spread out. Sorry. Okay? Those little lines coming off, it means they're moving quick. So gas particles are very spread out and constantly moving. Constantly moving. Air particles are colliding with your face at all times. It's like trillions of punches to the face constantly. How come you don't feel it? Because you're used to it. I'm going to answer that for you. When are you not used to it? When you go on a plane or change elevations. Then you feel it. Your ears feel it first. That's when you feel the difference. We'll talk more about that. Particles are very spread out, constantly moving. Very weak forces of attraction. That's why they are so far apart. Gas particles hate each other. That's why I always say they hate each other. They want to get away. They want to spread out. Are very spread out. Weak forces of attraction, constantly expanding. As soon as you take a breath, well, exhale, that's trying to fill up this whole room. Okay? So, oops. Let me write that down. Fill their container. That's what's cool about gases. If you have 1 liter of gas and pump it into a 2-liter container, now you have 2 liters.
How does that work?
Because it fills the container. But the number of particles are the same. So if you have a container that is 1 liter of neon and I pump it into a 2-liter container, so I go this way, let's say I have 1 million particles here, I still have 1 million particles here, they just spread out.
Yeah, I get it.
Mr. McCoy,
Yeah.
how come gas is called gas if it's liquid?
Wow, what? What do you mean it's liquid?
Car gas, isn't it?
Oh, because it's called gasoline. So the real name is gasoline, but people just don't talk like that. You know, it takes too much effort. I'm gonna go get some gasoline.
It would be
people
cool
say
if it like
gas.
filled up a 2-liter one if it was in the 1 liter.
You're right. You can save money that way, right?
Yeah.
So anyways, I didn't know what you meant for a second. Fill their container like I was just talking to Cody about. And last thing here, no definite shape or volume. And again, the reason for all of this is because they have very weak forces. They're constantly moving, very spread out. Oh, one more thing, sorry. Easy to compress and expand. Easy to compress and expand. Sorry, I'm running out of time, going quick. Yeah, because there's big spaces, like if these desks were spread out throughout the whole room, we would be able to get you closer because there's spaces. We'll talk more about gases tomorrow.
Do you have one of those home? Oh, I know you gave me.
I think I gave it to you, yeah. Don't forget